name is Jonathan Denzel. I'm the project and technical lead for the NEUDOSE high-altitude balloon mission. So the NEUDOSE high-altitude balloon mission is launching a prototype of our satellite, which we'll be sending to space. We're going to be sending all the custom hardware and testing the software on a stratospheric balloon mission, which means the balloon is going up to 100,000 feet, and it'll be exposed to very harsh environments with very cold temperatures of around -50 degrees Celsius. So we'll be able to test, the solar panels and their efficiency. So the wider satellite mission that we are doing will house a state-of-the-art radiation detector on it, which will help keep our astronauts safe when they go on long-term missions like to the moon or to Mars. The success of this balloon mission is very critical to the team because it'll build expertise within the team to manage and run a balloon mission, so that after we launch the satellite and we have many more satellite missions to come, we'll be able to test those custom hardware and software on our own balloon missions.
Hi, I'm Deanna Dumitrescu. I'm an engineering manager for the wider NEUDOSE mission and a senior mentor for the SBX team. We're pretty much composed of a lot of people with science backgrounds or engineering backgrounds. So anything from second years all the way to like fifth years and graduate students. We really encourage having the younger students on board too, because for us, student learning is probably the #1 goal. We hope that maybe sometime in the future, it'll branch outside of science and engineering and incorporate a lot of the other important aspects when it comes to anything related to space or space missions. But when it comes to the day-to-day, it really depends on the student to come up with their own schedule. So on top of school, they might do maybe half an hour or an hour of maybe small technical changes, some research, or maybe they just have it once a week where they're working fully on NEUDOSE. The pandemic wasn't too bad, but that's only because we were fortunate enough to already have a really good online infrastructure where we had a lot of stuff set up for online meetings already, like an online workspace. But the hard part was that we all of a sudden lost our accessibility to resources, any type of lab equipment or lab space that we really need when it comes to anything physical like manufacturing or testing. It kind of encouraged us to maybe try to be a little bit more creative or think outside of the box when it came to anything in terms of testing and working together in a physical space. One example of that might be that if there's one person that does have access to the lab and is able to go, then they can also go on a video call with multiple other members while they're completing some sort of procedure or doing some type of testing. And that way you still have people there incorporating their feedback and helping you live, as opposed to you trying to figure it out all on your own.
My name is Paula Bosca. I'm the lead of the command and data handling portion of the SBX mission. A lot of our project is made up of custom designs designed by our students. We have a custom communications module. So it's a printed circuit board with a bunch of components that lets it interface to some antennas to enable us to sort of communicate through radio. Of course, the entire structure that everything sits in is entirely designed by our students. So a lot of really custom designs, which is pretty cool. With this many components that sort of all interact, there's a lot of challenges along the way. One that sticks out to me is the design of our battery system. It's something that affects really everything else. And so we sort of decided to go with a bunch of like Energizer batteries you could buy at the store, really. But because of the sort of temperatures you see high up in the atmosphere, it gets really cold, you need to insulate it, so you need a holder. But then the moment you start adding anything to your design, that increases the mass. We all came together and we reviewed it in what is essentially a big pro-con list of every single design. One of the most meaningful things is the ability to look at a system from a systems perspective. When you get to work on a project like this, you have to consider all these things you didn't before. Like if you're working on like a computer in a lab at a school, you don't have to worry about making sure it's at the right temperature. You don't have to worry about where does it get its where does it get its power? You just plug it into the wall and things like that. But when you design a system like this, you really have to consider and design all of those aspects. And when you change one of them, you have to think about how it impacts everything else. With these non-ideal conditions of being in the stratosphere and these other external requirements, you have to get really creative in some of your solutions to these problems. And so those two things really work in tandem, and I think are really valuable skills that I've learned and developed throughout this mission.
Like before I came into university, I was always interested in aerospace and, you know, being in space and all this stuff. I think just the idea of, you know, putting something on a balloon that goes to 100,000 feet and you get to test it and you get to work with so many smart people, that's just such a valuable experience for me. And I know I've grown so much, right? And I can say personally, like when I saw postings for, you know, positions in NEUDOSE, I thought, oh, I'd never make it in there. Like those people are like too smart, right? But you know, you just apply, just put yourself out there and do it, and you never know, you know, like opportunities open, and this has definitely been a great opportunity for a lot of people.